Triangle ABC with vertices A 1, 1, B 1, 4, and C 3, 1 is shown on the diagram. Triangle ABC is mapped onto triangle LMN by a reflection in the x-axis, followed by a reflection in the y-axis. Draw and label triangle LMN. So the statement of the problem that we have right there says that this original triangle is reflected in the mirror line, which is the x-axis, then reflected in the mirror line, which will be the y-axis. Then the result will be triangle LMN, and we are required to draw and label that triangle LMN. Triangle ABC is mapped onto LMN by a reflection in the x-axis. The mirror line is the x-axis, as we have it shown there. Begin by reflecting the point A. So we are going to do it point by point. Begin by reflecting the point A in the mirror line. First, the line joining a point to its image is perpendicular to the mirror line. But it's not difficult to draw a line that is perpendicular to the mirror line, because on the grid we have vertical and horizontal lines. Any line that is vertical is perpendicular to any line that is horizontal. Therefore, it is not difficult for us to have the constructs of the lines that should be perpendicular to the given mirror line. As a matter of fact, the grid has only vertical and horizontal lines, so we should have all of those required lines at our disposal. In order to find the image of A, as we said before, the line joining a point to its image must be perpendicular to the mirror line. So from A, we have a line going to the mirror line that is perpendicular to the mirror line. And what is next? A point and its image are equal distance from the mirror line. A point and its image are equal distance from the mirror line. This means that the distance of the image of A from the mirror line will be the same as the distance of A from the mirror line. The distance of the image of A from the mirror line will be equal to the distance of A from the mirror line, and we will show that like that. That line segment that we are using as the distance of A from the mirror line is used as the distance of the image of A from the mirror line. There we have the image of A. And take note that we don't have to be too bothered about the line joining a point to its image being perpendicular to the mirror line, because every line that we have, every vertical line, is perpendicular to the mirror line, which is the horizontal line, which is the x-axis. Reflecting the point B in the x-axis is analogous to reflecting the point A in the x-axis. So in the same manner that we reflected the point A in the mirror line, we will reflect the point B in the mirror line. And pretty much that is the same way that we do all reflections. The line joining a point to its image is perpendicular to the mirror line. And look at B right here. If we take this line of the grid, which of course coincides with one of the sides of the triangle on this occasion. So if we take this line that goes from B down to the mirror line, of course that is perpendicular to the mirror line. It is a vertical line. The line joining a point to its image has to be perpendicular to the mirror line, and that vertical line is perpendicular to the mirror line. Then what we need the image of B to be the same distance from the mirror line as B is from the mirror line. So from the mirror line to B, the same distance must be from the mirror line to the image of B. And we will show that by maintaining our line segment and placing it on the other side of the mirror line. So the point and its image are equal distance from the mirror line. And there we will have located the image of B. What do we do next? Finally, let us reflect the point C in the same fashion. So the line joining C to its image must be perpendicular to the mirror line, which is not difficult because all vertical lines are perpendicular to the horizontal x-axis. Then the distance of C from the mirror line will be the distance of the image of C from the mirror line, which is going to be depicted by the movement of this line segment to the other side of the mirror line. So that distance is the same. The image of C will be shown. Although it is not required by the statement of the problem, we may complete the triangle which results from reflecting ABC in the x-axis. It is not a requirement of the statement of the problem, but we might include that triangle in order that the diagram may be more visually friendly. Then we will go ahead and reflect the resulting triangle in the mirror line, which is on this occasion the y-axis. So we have it here, followed by a reflection in the y-axis. The concept is the same. The mirror line is the y-axis on this occasion. Begin by reflecting the image of A in the y-axis. And do not forget, the line joining a point to its image is perpendicular to the mirror line. And on this occasion, the mirror line is the vertical y-axis. Therefore, any line that is horizontal will be perpendicular to the mirror line. So we'll go straight ahead in finding the image of A, which we will have a horizontal line going from the image of A to the mirror line. There it is. Additionally, a point and its image are equal distance from the mirror line. Therefore, we will take this line segment and fit it the same distance on the opposite side of the mirror line. There we go, and that will be the image of A. So we do not need to be cumbered by the fact that a line joining a point to its image should be perpendicular to the mirror line, because our grid is a lovely network of horizontal and vertical lines which are perpendicular to each other. That makes it easy for us. Reflecting the image of B in the y-axis. So we will do that. Reflect the image of B in the y-axis. The line joining a point to its image is perpendicular to the mirror line, just as before. And what else? And a point and its image are equal distance from the mirror line. Equal distance on the other side. So there we have our image of the image of B. Then we will reflect the image of C also in the same manner. And we have right there the line segment going from C to the mirror line, which is horizontal and has to be perpendicular to the mirror line, therefore. Then we have 1, 2, 3 units, but we don't need to check, because on this occasion we are just replacing the line segment on the other side of the mirror line. However, in your work, it is going to be important for you to ensure that the distance from C to the mirror line is the same as the distance of the image of C to the mirror line. And of course, you might want to check the number of units, like we have 1, 2, 3 here. So we have 1, 2, 3 units. On the opposite side, we will have 1, 2, 3. So the image of C will be right here. Good. Do not forget these two very important notes. That the line joining a point to its image must be perpendicular to the mirror line. And a point and its image are equal distance from the mirror line. On this occasion, drawing the resulting triangle is a requirement of the statement of the problem. Here we have it. Draw and labeled triangle LMN. So we should finish up by completing the triangle LMN, which is going to be the final resulting triangle. And there it is. So there we have the triangle LMN. Now we cannot just label the triangle LMN. We have to be certain that where we put the label will actually be the result of the transformations on the original points. So we have to be systematic about it. So the point that is actually the image of A will actually have to be shown to be the image of A. Labeling the resulting triangle must be done according to the statement of the problem. Labeling the resulting triangle must be done according to the statement of the problem. Triangle ABC is mapped onto triangle LMN as we have it there. It means that the image of A is L. There we go. The image of A is L. So A, we are going to take a look at the movement of A in arriving at our final answer. So A begins right there, and the image of A is that one, which is L. And we will do the same for the image of B, which is M. So the image of B is M. The image of B is M. What else do we say? The image of C is N. There we go. So we have to ensure that we just don't put LMN anywhere, but we put L as the image of A, M as the image of B, and N as the image of C. In the next phase of the problem, we will be required to tell which transformation maps triangle ABC onto its image LMN. So in the next phase, we will demonstrate how we arrive at our answer, but we need to describe the transformation that maps triangle ABC onto its image LMN. Now, what we did for the triangle ABC is that we reflected it twice. And by reflecting it twice, the mirror lines were not parallel. If the mirror lines were parallel, then that would result in a translation. The mirror lines are not parallel. It means that the transformation will be a rotation. So we know ahead of time that it is a rotation. As a matter of fact, if you did not know ahead of time that it is a rotation, you would be able to look at triangle ABC and LMN and still arrive at the conclusion that it is a rotation, because transformations have their particular properties that students should know. Going from here to here, a student might be disoriented by the transformation. But we know that if we have a circumstance like this, that we could check the orientation of the two triangles, and if they are of the same orientation, which they are, then we know that it is definitely a rotation, and then we will have to just complete the entire description. So that should not be too much of a problem if we did not know ahead of time. But because we know ahead of time that if the lines are parallel, the result is a translation, but they are not parallel. If the lines are not parallel, the result is a rotation. So we know ahead of time that the result is a rotation, even without checking the orientation of the two triangles. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.